In this video, we will discuss about what have you learned. So we will brief up or we will summarize everything that we have learned in this chapter, electricity. A stream of electrons moving through a conductor constitute an electric current. Conventionally, the direction of current is taken opposite to the direction of flow of electrons. So how does this electric current produced? So this electric current is produced because of the flow of electrons. As the electrons move, electric current is produced or generated. But conventionally, the direction of current is opposite to the direction of flow of electrons. For an example, if the current is moving towards the right, then the flow of electrons, the direction of flow of electrons will be towards the left. So both are opposite in direction. The SI unit of electric current is ampere. We know every quantity is measured and every quantity has a particular unit. For example, milk is measured in liters. Distance is measured in kilometers and meters. So like the same, this quantity called electric current is measured in amperes. So ampere is the standard unit of electric current. To set electrons in motion in an electric circuit, we use a cell or a battery. A cell generates a potential difference across its terminals. It's measured in volts, capital V. So if you just look at this particular picture, you can see a battery here. So a battery has to continuously expend its chemical energy, and this energy will create a potential difference across the terminals. So this is a positive terminal and this is a negative terminal, and a potential difference is created across these terminals, and because of this potential difference only the electrons will move. And this particular potential difference is measured in volts, which is represented by capital V. Now if you can look at this picture, we can relate this picture to the first point also. You can see the electrons are moving in this direction. So you can see they are moving from the anode to cathode. That means the flow of current will be in opposite direction. That means the flow is towards cathode to anode. We always know that current moves from positive terminal to negative terminal. So it moves from cathode to anode. Resistance is a property that resists the flow of electrons in a conductor. It controls the magnitude of current. The SI unit of resistance is ohm. So resistance is a property which is generally observed in all the conductors, and this resistance will always oppose or stop the flow of electrons. It controls the magnitude of current, and resistance is measured in its SI unit called ohm. Ohm's law. The potential difference across the ends of the resistor is directly proportional to the current through it, provided its temperature remains the same. So the potential difference across the ends of a resistor is directly proportional to the current if provided that the temperature remains the same. That means V is proportional to I. Potential difference is proportional to I when the temperature is constant. And this Ohm's law is proposed by a scientist called Ohm. The resistance of the conductor is directly dependent on its length and inversely on its area of cross section and also on the material of the conductor. We discussed this point very briefly in factors affecting resistance. We took the example of road and traffic. So if you can observe this particular point, the resistance of a conductor directly depends on length. That means it is directly proportional. As length increases, resistance also increases. As length decreases, resistance also decreases. And it is inversely proportional to the area of cross section. That means if the width increases, then resistance decreases. If width decreases, then resistance increases. That means it is inversely proportional to the area of cross section, and it also depends upon the material of the conductor, what that conductor is made of. The equivalent resistance of several resistors in series is equal to the sum of individual resistances. So we know resistors are usually connected in two forms. One is the series and parallel. So if we want to calculate the equivalent resistance of several resistors in series, then the sum of individual resistors will be the equivalent resistance. So if you can see, if you want, this is the equivalent resistance. So equivalent resistance in series combination will be equal to sum of individual resistances, which will be R1 plus R2 plus R3, R4, R5 and so on. So it will be the sum of all the resistances. The equivalent resistance of several resistors in parallel is equal to the reciprocal of the sum of individual resistances. So if it is in parallel, that means the equivalent resistance will be the reciprocal. Reciprocal means 1 by the value. The reciprocal of the sum of the individual resistances. That means 1 by R total, that is equivalent resistance, will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. The reciprocals of all the individual resistances. So that will be in parallel. The electric energy dissipated in a resistor is given by the formula. So whenever we use any electrical appliance, apart from the electricity produced, there is some energy or heat that is dissipated, and that is given by W is equal to V into I into T. That is, work done is equal to V, potential difference, into I, current, into time, which is T. So work done is equal to potential difference into current into time. W is VIT. The unit of power is watt. W. 1 watt of power is consumed when 1 ampere of current flows at a potential difference of 1 V. So the unit of power is watt. So power is measured in watts. It is a standard unit. So 1 watt of power is consumed when 1 ampere of current flows at a potential difference of 1 V. For example, consider there is a bulb. So this is a bulb. And if this bulb consumes 1 ampere current at a potential difference of 1 V, then we say the power of this bulb is 1 watt. So that is how you calculate watt. Commercial unit of electric current. So if you want to measure electric current commercially, then you will use another unit. So the commercial unit of electric current is kilowatt hour, kWh. K is kilo, W is watt and H is R, kilowatt hour. So 1 kilowatt hour is equal to 36000000 joules. Now, how do we get this value? We discussed it in the previous videos. So, R is not the SI unit. So, we convert this R's into seconds and kilo is 1000. So, on multiplying, we get 36000000 joules. And we can write this as 3.6 into 10 to the power of 6 joules. So there are 5 zeros here, 1, 2, 3, 4, 5. So 5, 10 to the power of 5. And since we added a decimal place here, we will write it as 6. So it is 3.6 into 10 to the power of 6 joules. Thank you.